Throughout the day, you're being moved around by powertrains, mechanisms that turn energy from engines into movement. It's what turns liquid gas into useful movement that helps you get around.
Our technical principle is efficiency. Efficiency, in technical terms, is the amount of useful work over the total power produced by an engine. But you can also think of it as how much power gets turned into movement, or how much is lost along the way.
But while powertrains are different, not all are created equal. Different powertrains have different sources of power with different efficiencies, as well as other associated trade-offs. Here's a rundown on the 4 major types you'll find in everyday cars.
Gas powertrains are most efficient at high rotational speeds when the internal pressure of the engine is performing at its maximum potential, and little power is being lost as residual heat. However, the relation is not linear. At lower speeds, a much greater amount of energy is expended relative to work completed. Honda Civics are an example of natural gas cars that were recently introduced into the market.
Diesel powertrains, like gas powertrains, operate using an internal combustion engine. Diesel engines are more efficient than gasoline engines because it relies on combustion ignition as opposed to spark plug ignition, meaning there is less work done on the system to generate work. For examples of diesel cars, look no further than most Fords.
Hybrid powertrains operate on electricity in low speeds and use gas on higher speeds where it operates at a higher efficiency. Furthermore, they often use excess braking energy as regenerative to the battery. When both the gas and electric engines are operating, overall the powertrain has less energy waste than the traditional gas and diesel models. A Prius is a well-known example.
Electric powertrains consist of a high-voltage solenoid motor and a relatively simple drivetrain. Due to this, the loss of energy through heat, usually associated with an internal combustion engine, is very limited. However, the magnetic resistance inside the solenoid engine does not allow the vehicle to maintain momentum without continuous acceleration. Thus, the magnetic resistance results in a loss of energy.
Seems simple enough, right? In reality, choosing between powertrains is a big deal. Each one has its own different type of fuel, which carries with it different limitations for engine and vehicle design, as well as different ideal functions for the final product.
For our project, we wanted to center on one trade-off that's especially pertinent today: environmental efficiency versus the power.
Power is the rate at which work is done, or the amount of work done over a given period of time. It can be quantified in units of power, typically watts, which are joules over seconds. In cars, it is not uncommon to hear power measured in horsepower. 1 horsepower is equal to roughly 746 watts.
In every powertrain, there are 2 primary types of emissions: production and tailpipe.
In combustion engines, like diesel engines, tailpipe emissions are the big worry. The combustion reaction that creates power for the car also creates carbon dioxide, a noted greenhouse gas. Furthermore, the efficiency of these engines can be chronically low, as little as 30%.
Natural gas is a low-carbon, cleaner burn, which means its emissions are substantially lower than diesel engines. However, while the use of natural gas as an alternative fuel is improving, these engines typically are less powerful than the diesel alternative.
Electric cars would seem to be the natural winner, but they are not without their drawbacks. At high rotational speeds, an electric powertrain is just as powerful as a diesel one and produces no tailpipe emissions. However, the production emissions of the battery are substantial.
Hybrid engines look like the best of both worlds. The power of a combustion engine with the lower emissions of an electric one, but they still carry drawbacks of both of them.
The emissions, the climate impact, and certainly not just from what comes straight out of the tailpipe, but from the whole life cycle. I really do think it's important that we consider sort of the cradle to grave impact of these technologies, and even things like some of the emission control technologies that we use in these vehicles use a lot of precious metals and materials that are rare and expensive, and it's put from I would like to see from every stage of the design process sort of keeping climate, air pollution considerations in mind.
When considering what powertrain is the best, low environmental waste should be a priority in designing efficient powertrains. We recommend electric powertrains as the best model because while there are emissions associated with their production, they have 0 tailpipe emissions.
I think certainly, if mandates around new vehicle production from Clean DC stick, that there'll be a lot more electric and hybrid vehicles on the road. And I think for a lot of the big trucks, and certainly shipping in and around Vancouver, you'll see a lot more natural gas engines as well. That seems to be currently sort of technology people are interested in.